All right, so I wanted to show you how to show you some problems from 7.3 and 7.4. And in 7.3 and 7.4, we're adding and subtracting rational expressions. Okay, so let's just look at a couple examples. So, maybe I have something like this. 5x squared plus 4x over x minus 1 minus 6x plus 3 over x minus 1. Let's do plus. Let's do plus to keep it simple. All right, so the way this works is we're adding fractions. So you got to remember, if you're going to add or subtract fractions, you have to have common denominators first. And we do, right? So if we have common denominators, then the nice thing is this. The answer is going to have the same denominator. We don't have to do anything to get the denominator. It's just going to be the same denominator that was. On the top, though, you just simply do this. Let me change that. The top plus the top, right? Once they have a common denominator, then you're just going to do top plus top, and you're good to go. So it's 5x squared plus 4x plus 6x plus 3. And then, of course, you'll combine those things. 5x squared plus 10x plus 3 over x minus 1, right? So if it's common denominator, then you just add the tops if you've got a common denominator. Let's look real quickly at if this was a problem. This was a subtraction problem. Same rule applies. That is, if you have to have a common denominator. Let's put it down here. So if you have a common denominator, then the answer is going to have that denominator. Now here's what you got to remember with subtraction. You're still going to do the top minus, but if your second thing, if the thing you're subtracting, if your second term, this guy right here, if it's got more than one term, you want to make sure you put it in parentheses like I did here. So, and that's if you're minusing, if you're subtracting, right? Because when you come back to this, you want to, that minus will distribute through and give you a negative 6x minus 3 over x minus 1. So 5x squared minus 2x minus 3 over x minus 1. And there it is, okay? So if it's a subtraction and you're subtracting multiple terms, then that's what you've got to do. You've got to put parentheses around that. Okay, so what if you don't have common denominators? All right, the short answer is you've got to find them first, okay? So let's look at an example with that. 10x over x squared minus 9 minus 5 over x plus 3. Okay, can't subtract them because the denominators are different. So we've got to find them. Now, in order to find common denominators, the first thing you have to do is factor the denominators that you have if they need to be factored. So x squared plus 9 needs to be factored. And so we factor it into x minus 3 and x plus 3. Minus 5 over x plus 3. Okay. Now we're ready to try to find the common denominator. And so the way you do this is you look at the denominators you have, now that everything's been factored, and you notice in all the denominators, I have an x plus 3. So that means my LCD needs to contain an x plus 3. Okay, because that's one of my denominators. All right, what other denominators do I have? Well, I have an x minus 3. That x plus 3 I've already accounted for, but I have an x minus 3. So that means I've got to include an x minus 3 as well. So my common denominator, my LCD, is x plus 3, x minus 3. So what I now want to do is take my original fractions, which are 10x over x minus 3 times x plus 3 minus 5 over x plus 3. And I want to make them so they both have this denominator. All right. Well, the first one does already. This guy is already good. Okay. So it's already got the denominator removed. But this one is not. And so here's what you do. You just say, What denominator do I have? An x plus 3. What denominator do I need? X plus 3, x minus 3. So I am missing an x minus 3. So we're going to multiply this one by x minus 3 on the top and on the bottom. And now it's got the common denominator. And so now I can just say, okay, my answer is going to be over, it's going to have the same denominator, x plus 3, x minus 3, so that's good news. And then on the top, it's going to be 10x minus 5 times x minus 3, or 10x minus 5x plus 15 over x plus 3, x minus 3. So it becomes 5x plus 15 over x plus 3, x minus 3, and then you just get a 5x plus 3, x plus 3, x minus 3. When we factor that out, right? Because we've got a factor, and see if we can reduce this guy. So you factor it, the top can factor, and then notice I'm going to be able to cancel the x plus 3's, leaving just 5 times x minus 3 as my simplified final answer. So, if you need to add or subtract fractions that don't have common denominators, you have to find common denominators first. And that's an example of how it's done.